everyone, welcome to my channel Pure Biology, and today I come with another video, that is LOTKA VOLTERRA model. Okay, so this is a topic related to predation, prey and predation. That means the interspecific or the intraspecific competition. Like that intraspecific competition, you all know that the competition of individuals within a species, and interspecific competition, that means the competitions of the individuals of a particular species with the other species. Okay, other species individuals. So this model is related to that interspecific or intraspecific competition. So here, this is a simple mathematical model which is represented by this. This generally helps to represent the interaction between two competing species. Interaction between two competing species, where this competition generally occur when you all know the resource that is common for the species 1 and the species 2. At that time, this competition is seen. So it is based on the another growth equation. This is called the Varust-Parl logistic growth equation. Okay, Varust-Parl logistic growth equation. So this equation is like that: dn dt equals to Rn bracket k minus n by k. Okay, so here in this logistic equation, okay, this logistic equation already I explained in my previous video, so you just check out that logistic equation. Okay, in this logistic equation, a rate of population growth is limited by intraspecific competition. So intraspecific competition means, intra means the number of same species competing with other, or you can say the individuals within the same species, they are competing with each other. And this equation can be modified to include the effect of interspecific competition as well as the intraspecific competition. So I already had said that logistic equation generally represent the interspecific competition and intraspecific and intraspecific competition. And on the basis of this logistic equation, this LOTKA VOLTERRA model is prepared. And this model developed to allow ecologists to predict the potential outcome when two species are in competition for same resources. I said that already, that generally by the LV model we can easily predict, or the ecologists they can easily predict the potential outcome, or what is the outcome when two species are in competition for the same resources. And basically this model attempts to account for the effect that the presence of one species will have on the population growth of the other species relative to the competing effect that two members of the same species would have on each other. What is saying that? That means we can also predict how the growth of one species is affected by the other species presence, or the presence of other species. Okay, so this logistic equation and LOTKA VOLTERRA equations for two species, that is species 1 and species 2. These are the equations. For species 1, when the species 1 only alone, or they growing only alone, in that situation the equation is that one. Okay, dn1 dt equals to r1 n1 bracket K1 minus N1 by K1. Okay. Here the 1 is for the species 1. Now this species, what is happening to the equation if this species is affected, or the presence of another species that like 2, presence of another species that like 2, what will be the equation for the species 1? In that situation, that will be dn1 dt r1 n1 k1 minus n1 minus alpha 1 2 y1 2, 1 for species 1, 2 for species 2. That means alpha 1 2 is the constant and this is negative and it is the coefficient. What is the coefficient? That means that will be never change. And this coefficient 1 2, that means one species is affected by the presence of species 2. That's why it is alpha 1 2, not 12. Alpha 1 2, 1 for species 1, 2 for species 2. So we just simplify that in such way: r1 n1 k1 by k1 minus n1 by k1 minus alpha 1 2 n2 by k1. So what is happening? This cancel and we can write in such a way: r1 n1 1 minus n1 by k1 minus alpha 1 2 n2 by k1. Okay, so this is the actual equation. Same way, if the species 2 that growing alone, so here is the equation. Here is the equation: dn2 by dt equals to r2 n2 k2 minus n2 by k2. But when what will be the equation if species 1 is present? Okay, so in that situation, dn2 by dt r2 n2 k2 minus n2 minus alpha 2 1 n1 and k2. Okay, so in that situation, just we have to simplify this one. So r2 into k2 by k2 minus n2 by k2 minus alpha 2 1 n1 by k2. Okay, so here k2 and k2 both are cancelled. So alpha 2, r2 into 1 minus n2 by k2 minus alpha 2 1 n1 by k2. This will be the equation. Okay, and here n1 n2, what are these? n1 n2 are the population of the species 1 and 2. k1 k2, these are the carrying capacity. Okay, for species 1 k1 and for species 2 k2. Okay, and t is the time, small t is the time, and alpha 1 2, I said that competition coefficient, and 1 2 is the competition coefficient. First one that representing effect of species 2 on the growth of species 1. Okay, 1 and 2, that means effect of species 2 on the growth of species 1. This is alpha 1 and 2. And next one, this is the alpha 2 and 1. Here the presence of species 1, that affect how the species 2 is affected, or the growth of the species 2 is affected by the presence of the species 1. Clear? This is the alpha 2 1. It is another competition coefficient. For here the presence of 1 species 1, how affected or how affect the species 2. Clear? So these are the equations. Okay. Next we have to understand the coefficient about the alpha 1 and 2 and alpha 2 and 1. Okay. So first I have to write this one, and after I will try to explain it. Okay. So here the competition coefficient is constant quantifying the negative effect. Okay. So competition coefficient, it has the negative effect of an individual of a species. Okay, of a species on the population growth of other species. Okay, other species, and the value of competition coefficient is the ratio of the competitive effects of each species. So what is saying that competition coefficient, it has the negative effect of an individual of a species. Okay, and on the population growth of other species, that means due to the other species, the first species, suppose you can consider two species 1 and 2. So if the two species there, that means there is a negative impact is seen on the species 1. Okay, and it is measured by the ratio of the competitive effects of each species. Suppose the example is that if one individual of species 1 had the same competitive effect on the population level of the species 1 as 10 individuals of species 2. What is saying that? That means 1 is in the population level, suppose the one individual just have the not same behavior, that means you can say that same competitive effect. What is saying that if one individual of species 1 had the same competitive effect of species 1 as 10 individuals of the species 2, that means one individual of species 1 has same effect due to presence of 10 individuals of the species 2. You can understand? What is saying that one individual of species this may be affected by the presence of 10 individuals of the species 2. In that situation, what will be the competition coefficient? This is the ratio, that means 1/10. Okay, how these are affected? That means 10 individuals of the species 2 present, that's why the species 1 individual is affected. So the ratio will be 1/10. This is equal to 0.1. So that means this coefficient, if the value of this coefficient lesser than 1, suppose the value of coefficient lesser than 1, that means the effect of species 2 is less on species 1. Clear? But if this value is greater than 1, that means the effect of the species 2 is greater on the species 1. Clear? So this is the actually prediction, you can say. That means by understanding the competition coefficient, this is called the competition coefficient, by predicting or by calculating the value of competition coefficient with the help of the ratio of the species 1 and 2, that means how much individuals are affected of the species 1 by the how much individuals of the species 2, that means species 1's individuals, how much species 1's individuals affected by how much species 2's individual. Okay, this is the ratio, and by that way we can calculate this competition coefficient value. So if the competition coefficient value is lesser than 1, so that means the species 2's effect is less but on the 1. But if the value greater than 1, so that means the species 2's effect is greater on the species 1. This is the actual the calculation. Okay. So here some assumption must be there. That means when these predictions generally calculated, there are 4 assumptions taken for this calculating of this competition coefficient value. When so 4 assumptions are there. 1, R, alpha and K. These are all constant. Second one, every individual within each population is identical. Third one, the populations are not allowed to diversify. And the fourth one, the habitat is homogeneous. If the 4 assumptions are there, that means the calculation of this competition coefficient value is possible. Clear? So this is the LOTKA VOLTERRA model, and it is the first part of this. And another topic related to this model, obviously we have to learn, and I will I will give the explanation in my next video. Okay. So thank you.